Let's get the mantra on the board here, right? So it is do the math, leave no doubt, BT, write it out. Solve multi-step equations. Three different types of solutions here. So let's look at the three different things that can happen when we have multi-step equations where variables could be on either side of the equation. Let's look at the first one here. I've got 7x plus 3 equals 7x. Remember what we worked on previously, and that was we want to just get the variable term by itself first. Let's get a single variable term. The zero pair for 7x is negative 7x. And now we have 3 equals 0. Now don't run and hide from this. 3 equals 0 is okay, because what we found is, and what we know is that 3 does not equal 0, which means that the solution for this is a null set, N-U-L-L set. That there is no solution, no value of x will make that equation true. All right, let's look at the middle one here. We have 3y equals 18. We want that y by itself, so let's divide by 3. Divide by 3, and we get y equals 6. If I put 6 back in there, and formally 3 times 6 is 18. Bingo! What we have in this one is what we're normally used to here. This is a single solution. The only number that will make this true is 6. If I put 4 in there, I have 12 equals 18. If I put 0 in there, I have 0 equals 18. If I put 10 in there, I have 30 equals 18. None of those are true. 6 is the single solution that will make that work. One more type of solution here. I've got 5z plus 3 equals 5z plus 3, which makes sense, but let's just do the math. Make sure you do the math. Let's subtract 5z from both sides, because we want one variable, and that leaves me 3 equals 3. 3 equals 3 is great. We would describe this as an identity set, or say that it has many, let me put a big or here, many solutions. And what that means is whatever value you put in for z, both sides will end up being true. So if I put 10 in there, I've got 50 plus 3 is 53. 10 in there, 50 plus 3 is 53. No matter what I put into that, this equation will be true. When we go on from this, what you'll see is that these three solutions end up forming a pattern of solutions that we can graph that are for specific situations when we have two different lines. Here's our first example for multi-step solutions, multi-step equations. We've got this. What we see here is distribution. Don't forget, distribution is saying 3 of that quantity, negative 2 of that quantity, which means that there's negative 2 times that negative 9. There's 3 times that negative 4. We need to distribute first. So let me just write just a little word right here. Distribute. So let's distribute first. So 3 times 6 gives me 18. 3 times negative 4x gives me negative 12x. And that's equal to, bring my equal sign down, negative 2 times 6x is negative 12x. Negative 2 times negative 9 gives me positive 18. Now what we've talked about is let's take care of the variable term first. Let's get it down to one variable term. So I'm just going to work left to right, which I usually do. So I'm going to add 12x to this. So negative 12x, positive 12x, that's 0. That's going to leave me 18. Let me write this as 18 plus 0. There's my 0. Then if I add 12x to that side, I've got to add 12x to this side. And I get 0 plus 18. Combine like terms. 18 equals 18, kablamo. Which solution set was that? Many solutions, or identity set. So what we have in this equation here is we have an equation that has many solutions. That no matter what we put in for x, it will solve to be equal on both sides. Second example, remember, distribution first, then we'll gather like terms, and then we'll start doing our algebraic moves to solve this. Let me switch over to purple for this one. So I've got 2 times 3x, which is 6x. Don't forget distribution goes to the second term, plus 10 equals positive 5 times 2x is 10x. Positive 5 times negative 4 is minus 20. Positive times negative... No, that doesn't make it there, does it? Oh, that's a critical thing here. Notice that those parentheses end here, which means that that 5 does not get distributed to that negative 4x. That negative 4x is not part of that quantity. So this is just a negative 4x on the end here. Now let's combine like terms and get us down to one variable term. I've got 6x plus 10, leave no doubt, write it out, equals 10x and negative 4x. When we put those together, we've got 6x minus 20. Let's get it down to one variable term. I'm going to subtract by 6x, subtract by 6x, and now I have 10 equals negative 20. We know what that means, right? Does 10 equal negative 20? Not in a million years. So what that means is that we have a null set. We have an equation that has no solution. Back here, there is nothing we can put in for x to make that work. You didn't think we'd get away with not having one with rational coefficients. So let's try one with rational coefficients. Nothing changes in what we're doing. It's just a number shown as a ratio here. So the first thing we're going to do, this is the first thing we've done every single time, is let's distribute. So I've got 1/2 x, that just is going to come down here, plus 2 times 3/4. So 2 times 3/4 looks like this, 2 over 1 times 3 over 4. 2 times 3 is 6, 1 times 4 is 4. That gives me 6/4 x minus 2 times negative 1 is negative 2 equals 1/4 x plus 6. Let's combine like terms. So I've got 1/2 x and 6/4 x. So I can write this as fourths because I need a common denominator when I add these. So that gives me 2/4 x. Let me just change this here to 2/4. 2/4 plus 6/4 equals 8/4 x. So I've got 8/4 x minus 2 equals 1/4 x plus 6. Now, I've got to get that 1/4 x and that 8/4 x's together. Now notice I didn't change this, right? Because I still have a fraction in play here. So let's subtract 1/4 x from 1/4, right? So 1/4 minus 1/4 x is going to give us 7/4 x minus 2 equals 6. Let's bring that up here so we have some room to work with it. 7/4 x minus 2 equals 6. No worries at all, we've done this before. Let's add 2 to both sides to give us 7/4 x equals 8. First lesson, solving equations with rational coefficients. We need this to be 1x, so let's multiply by its reciprocal to get x equals 8 times 4 is 32/7, or 4 and 4/7. Is that true? I don't know. We got to find out. Let's find out. When I do the check here, I'm going to use that improper fraction because I think that improper fraction is going to work for me better than anything else will when I put it into the equation. So let's go back to the beginning here. Here's our beginning. 32/7, so I'm going to take that out and put in 32/7. And I'm going to take this out and put in 32/7. And then I'm going to take this out and put in 32/7. Let's see how this goes. This is going to be great. So don't forget, we can do the math. It's just little bits and pieces now. We've got a bunch of multiplication to do first. Let's do that before we do this distribution. Here I've got 1 times 32 is 32. 2 times 7 is 14. Plus 2 times 3 times 32. Let's knock this one down a little bit. The 4 and the 32 work together. So that gives me 3 times 8, which is 24 over 7 minus 1 equals Here's that 4 and 32 again, so let's knock that down. Divide both by 8, or divide both by 4 to get 8. That gives me 8/7 plus 6. Whew. Okay. What is 1 in sevenths? 7/7. So, if I make this into 7/7, I'm going to cross that out and just write 7/7 in there. Now I've got 24/7 minus 7/7. 24 minus 7 is 17. So that's giving me 32/14 plus. All right, here's where we were when I was rudely interrupted by my battery running out. So let's finish this problem. We've got, we're simplifying this right here. I've got 24/7 minus 7/7 gives me 17/7. And that's equal to 8/7 plus, let's turn that 6 into sevenths. So we're going to just multiply that by 7/7 to give us 42/7. All right, we kind of have a target to hit now. This is going to be 50/7 on that side. And let's look over here what we've got here. We've got 32/14. And 2 times 17/7. Let's turn this into sevenths. So we need to divide by 2 and divide by 2. And that's going to give us 16/7 plus 2 times 17 is 34. 7, look at this. So 16/7, 34/7 gives us 50/7 equals 50/7, which means our original solution all the way back here checks. Boy, that's awesome. All right, so just remember the keys to this are, there are 3, I gotta get my eraser, hold on. The keys to solving multi-step equations come down to being deliberate with your algebra, make sure you're acting equally on both sides, and just don't forget, like, you've got to believe the math that you're doing here so that, you know, you have 2 or 3 different ways that the solutions can come up here. Just don't forget that, right? Don't forget that we can run into a null set. You know, that's when we get something where it does not equal another something. So 2 does not equal 6. We can end up with a single solution. And that single solution looks like every solution that we've ever had. X equals 3, or maybe it looks like this, -3 equals x. It could be right to left or left to right, either one is fine. Or we can get an identity set, or also described as many solutions. And that equation should end up looking like something like this. 8 equals 8. Or -1/2 equals -1/2, where you have a value equals a value, and you've solved it. So this is a big one. Like, this is our leaping off point here, our jumping off point for where we're going to equations with 2 variables. So stick to it. Be deliberate with your math. Good luck.